In today's note, we're going to look at word problems. So in class, we started off by going over the different words that we could see in a word problem when referring to different operations. So I'm not going to go through them all again, but you can see them here. So for example, for addition, we may see the word sum or plus, increase, more than, rising, gain. So for subtraction, we may see the words less than, difference, minus, decrease, loss, deduct, and so on. For division, divide, quotient, goes into, split, separate, or cut, sharing, grouping, half, third, quarter, factor. And for multiplication, we may see things like product, multiply, something by something, times, power, double, triple, quadruple, or groups. So these things are important because as we go through some word problems, we may see these words rather than our traditional add, subtract, divide, multiplied. Secondly, what we went through are word problem steps. So these are some steps that you may want to consider as you go through the word problems. And these are helpful because it lets you, again, understand the question and find out key information. And we will kind of go through that process as we go through our word problems. So the first thing we wanted to do is read. We want to read the question, right? Make sure we understand what it's asking, but just it's key to read the question carefully. The second thing, or number two, is to read it again. Sometimes you may miss things first time around, or you may try to rush through it. If you take that second time to read it, hopefully you pick up on maybe some information that you missed, and if not, hopefully the question is too long and you just got a better sense of what it's asking. The third thing, underline key ideas. You want to underline the key things as you go through, or going back, what are the key ideas in the question. This can be tied into number 4, given information. So underline key ideas, underline and given information in question. That'll be helpful for when you go back and look at the question when you're trying to actually solve it, you'll know what's important or what's kind of already given to you. For number 5, what is being asked? This is important because, again, you're getting marked on what if you answer the question or not. Whether it's EQAO, a test, quiz, assignment, or just the homework, you want to know what is the question asking you. And this has slipped some people up previously in other questions is simple something as, say, for example, the question is asking for perimeter, but people or students decide to find the area, right? So make sure you understand what is being asked, what is the actual question. Number 6, do something. Apply knowledge or skill. So a big thing with these questions, you don't want to leave them blank. As long as you put something down, especially on the EQAO, you may get some marks. Even when it's just an in-class test or assignment, you still want to put something down, and then maybe that may spark kind of something inside you of what you have to do, right? So again, if you put something down, whether it's formula, rewriting given information, anything, it may spark something on, and you may figure out what to do. And lastly, did you answer what is being asked, and is it reasonable? So again, this goes back up to number 5, knowing what the question is asking. So did you answer that question? And as a part of that, does it make sense? Right, we talked about in examples with Pythagorean theorem, right? The hypotenuse is not going to be larger than, or is going to be the largest side. So if you get hypotenuse that is smaller than your other sides, then that does not make sense. That shouldn't happen, so maybe there's something wrong with that question. So that last little bit lets you kind of rethink about, okay, did I do everything right? Because my answer doesn't quite seem to make sense. In our first example, we want to find, the power P is in an electric circuit is related to voltage V and resistance R by the following formula: P equals V squared divided by R. And in A, we want to find the power P in watts when the voltage V is 100 volts and the resistance R is 25 ohms. So going back through this question, again, we read it once, we understand it. So if you don't, please read through it again. But we want to underline or highlight some important information. So obviously we want to know what the different variables represent. So voltage is V, power is P, resistance is R. That's important as well. Secondly, any given information. Well, we have our formula, so this would be important to know. You don't need to highlight it though, but just in case you maybe forget, that is important. As well as what the voltage and the resistance is. So that's important as well. Right, we want to know That's information that's given to us that we can use later on in our question. So the next step is what is being asked. Well, we want to find the power, right? We'll use a different highlighter. So the question that's being asked is find power. So that is important. Now we need to do something. Well, let's start off with our equation. So P equals V squared divided by R. So I start off with my equation, and now I know that I'm given the volts and the resistance, so I can plug those values in. So V would be 100. So it would be 100 squared divided by 25. So P equals 10,000 divided by 25. P equals 400 watts. So therefore, the power is 400 watts. So I've done something, I've answered the question, and it does make sense. It is a reasonable figure. B wants me to find the voltage given when the resistance R is 6 ohms and the power is 24 ohms. So again, same thing. I'm going to go through and highlight important information. So again, knowing what the variables represent, some given information. Well, the resistance is 6 ohms and the power is 24 watts. And again, what is the question asking? Find the voltage. So I can start off with my formula. P equals V squared over R. If I'm not sure what to do, let's do the same thing as the last one. Let's plug in what we know. We know the power is 24, and we know that equals our voltage, which is unknown, and our resistance, which is 6. So that is what we've gotten to right now, and this may look something similar to an equation, and based on our previous notes, we should be able to solve this equation. So let's rearrange, or let's try to get rid of this fraction. So if I want to get rid of this fraction, I'm going to multiply both sides by 6. On the one side, it cancels out, and I'm left with 24 times 6, which is 144. And that equals V squared. Now, knowing what we know from Pythagorean theorem, if I want to cancel out that squared, I need to square root both sides. So the square root of 144 equals V. So 12 equals V. So therefore, the voltage is 12 volts. So again, we've went through, we've solved, we've done something, we've answered the question, and it does make sense. Moving on to the next example. This one is less of a word problem, more just understanding the different terminology. So a number plus 5 then multiplied by 3 may be written as, so some key things here, a number plus 5. Okay, we can understand a number plus 5. We've talked about a variable, let's say x, represents an unknown number, and if I want to add 5 to it, or plus 5, that's what it will look like. Something key that I need to take into account is this then part. So what this means is I want to add first, and after I've added it, I have to multiply, or it wants me to multiply by 3. So this is what would, in words, a number plus 5 multiplied by 3 will be represented by x plus 5 in brackets times 3. The brackets come from the then part because we want to ensure that we're adding first and then multiplying. And example 3, none more than twice a number is 21. Determine the number and show proper form. So by showing proper form, I just mean show your work. So 9 more than twice a number is 21. So if we want to write this out, so 9 more than twice a number. So that's saying if we take a number, let's say x, and we multiply it by 2, if I add 9 to it, it equals 21. So here is my mathematical equation for that word problem. So now this is a two-step equation, so I can solve it by getting rid of this variable or this term first. So I'm going to subtract 9 from both sides to balance it out. Remember, the reason we're taking away the 9 first is because of opposite operations and the reverse bedmass. So I'm left with 2x equals 12. Now to get rid of the 2, I'm going to divide by 2 on both sides. So I get x equals 6. So, and that is my final answer. So again, in this short note, we looked at the different terminology for the mathematical operation, and we kind of went through some word problem steps.